Where the indirect function converts a text string into a reference, the offset function converts one reference into another reference through a fairly simple numeric approach. If it's so simple then, why did I start with the indirect function? Well, I think understanding the indirect function is easier because it converts a1 into a pointer to a1, which is a better starting process than saying that offset a1, 1, 1 converts a1 into b2. To understand offset, we're going to start by relating it to the index function. The index function, as you remember, takes a block of cells and then pulls the value from the row and column that you've specified. Now imagine that you didn't know which row and which column to end your array at. You only knew where the top left corner started. We could call that cell 0, 0, and each column down increases our left number by 1, while each cell to the right increases our right number by 1. That's how the base form of the offset function works. Plus, instead of returning the value from the cell, the offset function returns the whole reference. Of course there's more, but we'll start with that piece. As you can see here, I have a small table that is 4 columns wide and 3 rows tall. Each cell contains its relative reference to the upper leftmost cell, which is A3. In F3, I can write equals offset A3 2, 2, and I get the cell that says 2, 2. If I change A3 to A2, I get the cell that says 1, 2 since I've moved my starting point up 1 cell. This is somewhat similar to the index function, but still different. Inputting 1, 1 into an array from A1 to C2 would have returned the value in A1. Instead, using 1, 1 with the offset function moves me down 1 and right 1 instead of giving me the origin point. This difference lies in offset's row and column values indicating how many cells to move from the starting point. That means that the origin is technically 0, 0 here, while the index is indexing into an array and treats the first cell as address 1. Now let's look at our offset function helper in the formula bar, and notice there are 2 additional optional parameters that I've excluded so far, the height and width parameters. These parameters are where the offset function truly shines. The offset function's first 3 parameters help you determine where you want your range to start at. You start from reference A, move down X rows, and then move right Y columns. At that point, you want a range that is some number of rows tall, the height, and some number of rows wide, the width. We haven't encountered any places yet where the offset function would be hugely useful. However, we can construct a quick example using some higher level statistical functions. Many Excel functions are pretty specific about having the exact right size of data points and information. linest is among those. While I won't go into much detail about the linest function itself, I have constructed a small example for us to work with. In this example, I have a simple data series that I want to fit a line to. However, the data points might change depending on my dropdown. If you're a baseball fan, you'll likely recognize the names in this list. Bonds and A-Rod both have 22 years worth of data, while Pudge only has 20. Further, because 2 of Pudge's years were split, I've actually excluded them and knocked him down to only 18 total years, for simplicity and to support this example a little more. The data simply contains the number of plate appearances for the player and the number of wins that his team earned during the season, but that's irrelevant. With the data, I've set a linest function to estimate the impact of the player's appearances on the team's win total. It's simple and statistically flawed, but it's just an example for the offset function. I would normally write the function like this, which will work for both A-Rod and Bonds since they have the same number of years of data. But as you saw with Pudge, I get a pound value error since there's no data beyond year 19. I can use the offset function to handle this in conjunction with the count function. Since I need my height to always exactly match the number of items in my table, I can replace each component with an offset like this. I want to start by setting my reference to the very first cell in the column. Since I don't need to change which row or column I'm in, I'm going to set those offsets to 0. Now I want my height to be equal to the count of the column. Finally, I want my width to be 1, because I want to maintain that one column. A 0 doesn't make sense, and so you always need a positive value here. I'll do the same thing for the E's, except I'll do an offset E5 and a count E5 to E26. Inputting a value greater than 1 would indicate that you want more than one column wide, so you would include more columns to the right. Once I've done this, you can see that my function no longer throws the pound value sign. So that's a simple offset. What else can we do now? Well, perhaps we want to be able to change the subset of data that we're looking at with our analysis. Under a fixed formula, I could go in and drag each of the ranges to be just the data set that I want to look at, but let's do it a little bit differently. I'm going to add a field that says start year and put 4 in it. What I mean by this is I want my linest to start with year 4 and to exclude the player's rookie years in essence. I can modify my offset function to appropriately handle this by making it shift down by 3 rows, since 4 is 1, 2, 3 rows below 1. Once I've specified my new starting point, I'll also need to adjust my height to handle the size of the data set. If I look at my cells, I can see that I only have 16 instead of 19 now, which is 3 less than before. So I can figure that the starting point is the start year minus 1, and that my height is the count minus the start year minus 1. Now I have a regression function that updates based upon the player and the start year. I could go further and add an end year to cut off the last few declining years, and picking 14, so I can add some more logic to the height component by wrapping my count function with a min of count and match. Now I've constructed a statistical function that we can easily calibrate and that updates our range appropriately. This can be useful for constructing different types of averages or standard deviations to look at among a whole variety of other statistical uses. I can select different starting and ending years and watch my analysis update in real time without having to manually tweak my formula. The offset, like the indirect function, is a volatile function, so it faces the same issue with calculation efficiency. While it can be used to replace the index function, you most definitely should not do so, as you lose the significant calculation benefits of the index function, while also changing the value of the array index that you need. In our next lesson, I'll introduce you to a set of support functions, the row, column, and cell functions, for use with these other functions.